Now we're going to look at the composition of functions, and that means we are given two functions, f of x equals x squared, g of x equals x plus 1. And here with a composite function, we're looking at taking a function and substituting that into another function. Now, before I start this, I want to review real quick, how do we evaluate a function? For example, if I said I want you to find f of 3, how do we find this? Well, that says we're going to take function f, which is f of x equals x squared, and we're going to take 3 and plug that in everywhere there's an x. So we would end up with simply, instead of x squared, we would have 3 squared, which is 9. Or if I said I want to find g of 6, well, that says go to function g, and everywhere there's an x, plug in a 6. So we would have 6 plus 1, which is equal to 7. Now, here with our composite functions, we want to do the same thing, but we want to plug the entire function into the other function. And the notation that you're going to see used is f circle g of x, okay? And the other form is g circle f of x. Now, the way I like to write this, when you see f of g of x here, I like to actually write it this way, f of g of x, okay? Or down here, I would write this one as g of f of x. In the red, I just think this notation is a little bit easier to follow what we're trying to find. So basically treat this g of x just like we treat the 3 over here, where it says go to function f and plug 3 in, we get 3 squared. Well, if we're looking for f of g of x, then that means we're going to take, if we want to find f of g of x, then we're going to take and plug g of x into function f. So that means I'm going to take x plus 1, right? X plus 1 is our g of x, and we're going to plug that in for the x. So we would end up with x plus 1, the quantity squared. Okay, so then we could certainly square that, and we would have x squared plus 2x plus 1. So really what we're doing is we're plugging all of this x plus 1 in for the x. Now, if we're looking at it the other way, when we see g of f of x, then that means we want to go to function g. So here's function g, and then we're going to substitute function f in for that. So we want to plug function f, which is x squared. We want to plug all of that in for the x over here. So we would end up with x squared plus 1. So in place of the x, we're going to substitute in x squared, and then we have the plus 1. So that's all we're doing here with these composite functions is we're taking one function and plugging it into the other. So the notation again you'll see here is this f of g of x, and again I like to think of it as f of g of x this way with using the parentheses. I just think this notation is a little bit easier to follow. And that's all we're doing. We're looking at having a function inside of another function. So let's look at another example here. If we have f of x equals 3x plus 5, and g of x is equal to 5 minus x. So if we start out, I want to find f of g of x. So if I'm looking for f of g of x, then that means I'm going to take function g, which is 5 minus x, and I'm going to substitute that into function f. So that means in place of x, we're going to substitute 5 minus x. So we would have 3 times 5 minus x plus 5. And then, of course, we could distribute the 3. So 3 times 5 is 15 minus 3x plus 5. And 15 plus 5 is 20. And we have a negative 3x, so we could have 20 minus 3x. Now, what if I went the other direction? What if we wanted to find g of f of x? Now notice the different notation here. If I want to find g of f of x, that means I'm going to take the function f, which is 3x plus 5, and I'm going to substitute that into g over here everywhere we have an x. So we would have 5 minus, well, in place of x, we're going to plug in 3x plus 5. And notice I'm using parentheses because we have to distribute this negative sign. It's going to be distributed to everything inside of the parentheses. So we would then have 5 minus 3x minus 5. And here the 5's are going to cancel out, and we're simply left with a negative 3x. So again, all we're doing is substituting one function into another function. All right, now let me see if you can figure this one out. What if I said, again, we're using the same functions up here. F of x is 3x plus 5, g of x is 5 minus x. What if I gave you this notation? And if you want, pause the video and see if you can figure this one out. Well, this one says we're looking for g of x. Okay, that means we want to take function g and basically substitute it into itself. So let me rewrite this. So that means if we bring down function g, which is simply 5 minus x, we want to substitute its function g of x. We want to take g of x. Well, g of x is 5 minus x. So we want to take the 5 minus x and substitute that in everywhere there's an x. So we're going to plug that function basically into itself. So that's like finding g of 5 minus x. So we want to plug 5 minus x in for the x. So this would become 5 minus x. But what is x? Well, the x is going to be the 5 minus x. We want to plug it back into itself. So then once again here we would distribute the negative sign, and we would end up with 5 minus 5, and a negative makes it a positive x. The 5's cancel, so we're left with x. All right, so hopefully you're getting the hang of this. And the next example, you need to be very careful. It's a little tricky. F of x equals 3. G of x is equal to x plus 1. I want us to find g of f of x. So that means I want to take function f, which is the 3, and I want to plug the 3 into function g. So here we're taking function f, and we want to substitute that into g. So that means in place of x, we would have 3 plus 1, and that simply equals 4. Now that part's easy. Now what if I give you the other direction? And this is also easy if you understand the notation. We have f of g of x. So that means we want to take function g and substitute that into f. So here's function g, x plus 1, and we want to substitute that in over here to function f. Now everybody gets kind of confused here because if you notice, there's no x. We don't have an x to plug this into. Well, that's because this function is always 3. So it doesn't matter what we plug into it, this function is always 3. So the answer is simply going to be 3. And the reason that is we look at the graph of f of x. This f of x, where we have f of x equals 3, that's the same thing as saying y equals 3. Well, what's the graph of that? It says go up 3 on the y, and we have a horizontal line here, y equals 3. So no matter what your x value is, you could pick any x value that you want down here. For any x value, your y value is always going to be equal to 3. So that's why if we take x plus 1 and plug it in over here, function f is always 3. So it doesn't matter what it equals. So f of x equals 3, remember, this is called a constant function, and it's called a constant function because it's always constantly equal to 3. So keep that in mind. If you are trying to plug into that function, you realize there's no x, but that's because x can be anything. Your y value is always going to be equal to 3. And if we think of this using kind of your xy chart here, no matter what x is, if x is 0, 1, -1, or in this case, even if it is x plus 1, your y value is always going to be 3. And that's because it's a constant function. All right, our next example, we have the given function f of x equals the cube root of x minus 5, and g of x is equal to x cubed plus 1. And we want to find f of g of x. So once again, that says we're going to take our function g, this is the g of x, and we're going to plug that in for f. So we're going to take x cubed plus 1, and we're going to substitute that in over here for x. So that means we would have the cube root of x, but x is going to be x cubed plus 1, and we still have the minus 5. So then all we do is simplify, so we would have the cube root of x cubed plus 1 minus 5. We can just simply drop out the parentheses. So we have the cube root of x cubed, 1 minus 5 would be a -4. So here we have the cube root of x cubed minus 4. And then of course, if we want to find g of f of x, if you want to go the other direction, that means we're going to take f and substitute that into g. So here's function f, and we want to substitute that over here. We would simply get then x cubed, but x is going to be the cube root of x minus 5. So if we take the cube root of x minus 5, plug that in here for the x, so then all of this is going to be raised to the third power, and then we still have the plus 1. So if we simplify this, the cube root and the cube are going to cancel, so we're going to be left with simply x minus 5 plus 1, and so we would have x, -5 plus 1 is a -4. So x minus 4 would be your answer. So hopefully you realize here for these composite functions, you're just taking one function and substituting it into the other function.